What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And today we are back at it with, one second, more SAT math. And in particular, we're continuing this series on the new SAT that is going to be coming out in 2024. But for international students, it's going to be coming out in March of 2023. So it's right around the corner. College Board has released these 4 practice tests, and we're just going to make our way through them today. We are doing module 1 for practice test 2. So again, there's 2 math sections. It's a total of, we'd say, 70 minutes. But we're just going to do module 1 today, and that's going to be 35 minutes. What's up, Chris? Welcome back. Chris has been around for a long time on the channel, so it's super cool to see him again. The October 2022 SAT, I've done it. It's on my channel. So if you look at the, I think it's in one of my recent streams. I did it the day, I want to say the day that I checked my scores, and then I think I did it again. So it's up there. And yeah, that's it. I got a quick question. I'm doing December International. Stress, some people are saying December tends to be hard. Nah, these types of things are, there's no real pattern in terms of the difficulty. By the way, difficulty is not a bad thing because it means the curve is going to be more generous. So I often say on the math side, you kind of want a harder test. You want a better curve versus an easier test with less room for error. So that's my general opinion, but obviously it varies from person to person and test to test. But I wouldn't say there's a trend about December being hard. Is the material in the digital SAT? So far, I've taken like I said, right, I'm doing these tests for the first time in real time. So I haven't even seen this one yet. And the same thing last time. I would say that there were some questions that were interesting and different, slightly. Like there was that one rate problem on the first test that said minutes per mile instead of miles per minute or something like that. It gave a rate in kind of reverse order, which I just wasn't expecting and honestly hadn't seen on a regular SAT. So I wasn't even thinking to like slow down and consider that. So that was kind of cool. I think there were a couple other problems that were unique or different, but I would say overall it's the same material and it covers the same scope. There's not really anything new that I'm seeing here that I was like, oh, this was definitely out of the scope before. Yeah, this will be great practice for people taking it in person. And I think whether you take it in person, whether you take it digital, this will be good. Here's the thing, though. If you're taking it soon before it crosses over to the digital side, I would more likely recommend these other videos that I have on my channel that relate to the current SAT as opposed to this, which is the new SAT. And I see that Shai said, hey, you watched videos a few years back. Hey, I'm so happy they helped. What else we got? And appreciate been watching your videos. Took my score from 450 to 750. Wow, that's amazing. 300 points. Unbelievable. Yeah, I will do. Can you do one December math exam before the December test? The thing is, the December tests, I believe, are not released by the College Board, so I can't do them. You can only, can't get them. You can only get the ones that have been officially released, and that's what the College Board is cool with. They're not cool with, obviously, doing unreleased tests. That's their property, so can't do that. All right, guys, we got to start. We're going to jump into the mix. We set the timer for 35 minutes. I'm taking this for the first time in real time, so I won't be checking the chat anymore, but I'll check it at the end, and then we'll grade it, and we'll see how we do. Here we go. 3, 2, 1. Let's do it. Oops, too thick. Sorry. All right, here we go. The line graph shows the percent of cars for sale at a used car lot given model year. For what model year is the percent of cars for sale the smallest? It would be 2014. Just reading a graph. C is the winner. Done. Number 2, for a particular machine that produces beads, 29 out of every 100 beads have a defect. A bead produced by the machine will select the RAM. What's the probability of selecting a bead that has a defect? It's literally 29 out of 100. So again, probability, wait, it said that it has a defect, right? Yeah. It's literally the number of things that you're trying to find, right? In this case, something with a defect out of the total, which is 100, the entire population size. So let me just make sure I didn't go too quickly because it seemed pretty straightforward. Yeah, it's good. Done. Number 3, in the figure, line M is parallel to line N. Let's mark that. I like it. And that's a transversal. Not that you need to know that. What is the value of X? So check this out. We got interesting relationships here. If I know that this is 33, just if you go back to geometry class, this angle up here is 33 as well because they are called corresponding angles. Now, this is a linear pair. You don't need to know the terminology. What you need to know is on a line, that's going to be 180 degrees, which means X plus 33 is 180, which means X is 147. D is the winner. Done. Okay, number 4. What is the y-intercept of the graph? So the y-intercept is where it hits the y-axis. So this is something you might learn in pre-algebra or algebra. So the answer is that, but it's not, negative 8's wrong anyways, but it's 0, 8 because it's 0 on the x or y going left or right because that's the y-axis, and then going up 8, that's this part, boom, done. Okay. Number 5, let's go. Total cost after dollars lose car 36 months. Dealerships given this. So we got a function for how much money it's going to cost. X is the monthly payment in dollars. What is the total cost of lease a car when the monthly payment is $400? So that's your X value. We're going to straight plug and chug. We can use a calculator throughout on this test, but let's do it for fun mentally. Let's see if we can do this. So 4 times 36, 124 is 144, right? 4 times 36 is 144, and then you add the 2 zeros. So we add the 2 zeros. Then we'll add that 1,000 at the end. That's 15,400. Boom, done. Let me just make sure I didn't make a silly mistake. 400, so 10 months, 4,000, 8,000, 12,000, 13,000. Yeah, that's right. So did I miss anything? Nope. I think we're good. Number 6, each side of a square has a length. Guess what? Boom, boom, boom. Draw a square. Each side length has 45. What is the perimeter of the square? Well, perimeter is if it's all the side lengths added up. Here it's a square. They're all 45. 4 times 45, 160 plus 20 is 180. Now, this is a free response. This is what's interesting about the new test. They have free response kind of scattered throughout. You got to be triple careful when you do a free response question. Make sure you don't make a mistake because you have no multiple choice answers to guide you. So it's very important. 180, I'm going to do it one more time. 4 times 40. Well, let's even write it out. I mean, you really should use a calculator. I just don't feel like it. 20 carry the 2. 16 plus 2 is 18. Verified, boom, done. What is the positive solution to the given equation? So if we want to do this algebraically, I'm going to multiply both sides by x plus 6, right? So check it out. X plus 6 binomial, x plus 6 binomial. Boom, and I get 55 equals, those cancel out. X times x plus 6, which if I distribute that, that's x squared plus 6x. Now I'm going to set it equal to 0 because it's a quadratic. 6x minus 55. So then what multiplies to negative 55 and adds to positive 6 as we factor, right? So that would be 5 and 11, which the 11 is positive, that's negative. Because, you know, when you get that middle term, it's that 11 plus the negative 5x, which gives you a positive 6x. So my two solutions, what's going to zero this out? Well, that's going to be 5. What's going to zero this out? Negative 11. And we're talking about the positive solution. What's interesting is on this test versus the other one, I mean, the current one, you actually can have negative answers on the free response. Here, that's for positive, so what ifs. All right, number 8. An object travels at a constant speed of 12 per second. At this speed, what is the time? In seconds, it would take for the object to travel 108. All right, let's check it out. Let's use distance, 108, equals rate, 12 centimeters per second, times time. So we got this nicely, and everything's in the same unit, so we can feel comfortable about that. Centimeters for the distance, centimeters per second there. And we're trying to find the time in seconds again. So we can just set up this nice equation and then isolate by dividing by 12. So we can do that mentally. 108 divided by 12 is 9. 8 is the winner. Done. Let me just make sure that we aren't making any silly mistakes. 12 centimeters per second. Yeah. So 1 is 12. 2 is 24. 3 is 36, whatever. 9 would be 108. Boom, done. And again, some of you might be like, why did you even set up an equation? That was, I could intuitively know that. That's fine. I'm just giving you the framework and the scaffolding by which to structure the problems if you need it. But if not, and you're confident, that's fine. Number 9, the list give values of data set X and Y. Which statement correctly compares the mean of data set X and the mean of data set Y? Well, why don't we calculate? No, we don't need to calculate it. Check it out. This is amazing. If you make this little observation, this is really helpful and you can save a lot of time. Look, same. They're all the same except for data Y has one number additionally, and it's big. It's like an outlier. It's the big dog. So what is that going to tell me? Well, if it just had these, then it would have the same mean. And obviously, the mean would be between 13 and 5. Well, now we're adding a number that's bigger than the mean of Y, which means it's going to increase the mean. That means the mean of Y is greater than X. So it's B. The mean of X is less than Y, or Y is greater than X. Same thing. They're not equal. There is enough information because those are, it says, gives the values in the data set. So there's nothing we're missing. Boom, done. 10. A rocket contained 467,000 kilograms, blah, 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 exactly 21 seconds after the launch. Okay. I already know this is going to be, I think this is a linear equation. On the average, approximately how much propellant? Okay, so they're talking about on average rate of change, right? So we got two coordinates. So at time 0, it's got this much propellant or fuel, right? At time 21, it's got this much fuel. Guess what? These are two coordinates. So it says approximately how much propellant in kilogram did it burn each second after launch. Now, you can just probably calculate this by logic to a large degree because it's 21 seconds and whatever that differential is, right? You can divide it up. But I'm just going to go straight with slope formula because that is the rate of change, rate of burn per second. So check it out. We're going to use the calculator. And we're going to be very careful here. We're going to subtract out 4, 6, 7. Wait. Rock contained. Oh, yeah, it's going to be negative, but it doesn't matter. 0, 0, 0, because the right answer is not negative, but it doesn't matter. Minus 3, 6, 2, 1, 0, 5. Boom. Divide. And then it's that over 0 minus 21, which is negative 21. But again, I'm going to keep it positive because it doesn't really matter. It is a negative slope, if you will, because it's decreasing. But they gave the answers in these numbers. So A is the winner. Let's make sure we didn't make a silly mistake here. I especially like to do this when the answer we choose is kind of different than the other ones. And you see it's by far the small. So just let's make sure here. So each 21 seconds on average. So this is they provided this answer because that's the straight up difference. But then they want each second after launch. So you have to divide it by 21. Okay, we're good there. 11. 4 is 2, but do. Okay, so watch this. There's a nice little shortcut here. I can solve for x and plug it into this, or I can multiply both sides by 4. Okay, so why? If I multiply this by 4, guess what? I get 16x plus 8. So if you recognize that, that's amazing because then you do 4 times 12 on the other side, you get 48, and that's what they want. That's the answer. They don't want a value for x, which I think x would be like 2.5 or something. And then you can plug it in again if you want just to check. 2.5 times 16, that's 32 plus half of that, which is 8. 40 plus 8 is 48. Double verification, boom, done. 12. An object kicked from a platform equation. Okay, so we got a quadratic representing the height. As the height is ground, t seconds. Which number represents the height in meters from which the object was kicked? Oh, so that's your y-intercept. That's your height at time 0. So if we zero this out and this out, you'll see that you end up with 9. That's the answer. Boom, done. Let me just make sure I didn't make a mistake. Kick. Yeah, I'm pretty sure that's cool. All right, number 13. The given equation defines the function f. For what value of x does f of x reach its minimum? The given equation defines the function f. For what value of x does f reach its minimum? That is the vertex, right? So immediately when we talk about min or max, we're talking about vertex. The x value of the vertex, that's what they're asking about. For what value of x does it reach its minimum? Is negative b over 2a, which is negative 50, which is positive 50, over 2a, 2a, which is a is that front term, which is 4. So this is 50 over 8, which would be 25, 12.5, 6.75, right? No, 6.25, excuse me. 6.25. So I did that mentally. Obviously, we're going to double check it because it's free response. 50 divided by 8 is 6.25. Let's just make sure. Let me just think about another way to check this in negative b over 2. I'm pretty confident with that. It's fine. I'm not going to check it too much. All right. 14. A small business owner budgeted $2,200 to purchase candles. The owner must purchase a minimum of 200 candles to maintain the discounted pricing. If the owner pays $4.90 to candle to purchase small candles, $11.60 per candle to purchase large candles. Hold on. $4.90 small, large is $11.60, and we need 200. What is the maximum number of large candles the owner can purchase, stay within the budget, and maintain the discounted pricing? Wait, so do we need a system here? So $4.90. Oh, here's what we can do. So it's a minimum of 200. Wait, and then what is the maximum number of large candles? Wait, no, I don't even have to make an equation. This is much easier than I think, right? Because, hold on, the owner must purchase a minimum of 200 candles. What is the maximum number of large candles? So all we got to do is do 2,200 divided by 1160. That's it. Because that's assuming there's no restriction saying we have to buy a certain amount of small. What if they buy all large? So the maximum they can spend is this, which is, okay, 189. But the problem is they have to get at least 200 candles. So that doesn't work, right? Because so that we could say 189, but then we got no budget left to buy the small candles. So this is a little bit interesting, right? So let's say we do, okay, so we will set up a system. I'm going to backtrack a little bit. So we'll say 490x plus 1160 times 200 minus x. And we're just going to set this equal to 2200. I know it's not right exactly. And you know what, by the way, let me flip this around. I'm going to tell you why in a second. So I'm going to change this to 200 minus x and this to x. That way, as soon as we solve for x, we know we've got our correct answer, okay? All right, let's solve this. So we distribute. 2 times that is 980 minus 4.9x plus 1160x equals 2200. And then we're going to combine like terms. Negative 4.9. Let me just do it in the calculator. 11.6 minus 4.9 is 6.7. So 6.7x equals, subtract 980 from both sides is 1220. And then we divide both sides by 6.70. 6.7. 1220 divided by 6.7 is 182, but it's got to be less than, because it has to be a whole number, so we probably say 182. Okay, now let's check, right? Let's say 182, because we're going to go backwards now. 182 times 1160, 11.6, and that's that much money, right? 2111.2. And then we got to see how much money we have left, right? That minus 2200. And that's the amount we're going to spend on the smaller candles. So I'll divide it by the price of the smaller candles. And look, that's enough to get more than 18. So that's what we want. So this is probably 182 is definitely correct, because we get 182, then we can buy 18 of the others. We still hit the 200 max, 200 minimum. That's how we do it. Boom, done. All right, 14. Let's go to 15. In the linear function f of 0 equals 8. So it's a linear function, so I like to immediately turn it into coordinate notation. 0, 8, 1, 12. Which equation defines f? All right, so let's calculate the slope first. Subtract down. 8 minus 12 is negative 4. 0 minus 1 is negative 1. Negative 4 over negative 1 is positive 4. So the correct slope we see in B, C, and D. Then we also want to know the y-intercept, because these are in slope-intercept form. So let's do point slope. Oh, no, never mind. There's the y-intercept, 0, 8. So it's got to be 4x plus 8. D is the winner. And then if you want to verify, plug in 0, we get 8. Plug in 1, we get 12. Double verify, boom, done. 16. The function f of w equals 6w squared gives the area of rectangle square feet. And if its width is w and its length is 6 times the width. So if its width is w, length is 6w, which of the following is the best interpretation of this? All right. So what they're doing with this function is they're replacing or plugging 14 in for w, meaning this is the area of a rectangle with a width of 14. The area of a rectangle, of a width of 14 is this. So we verbalized it, we talked it through, we kind of understand what we're looking for. I always like to do this. I don't like to jump into the answer choices. Now we look at the answer choices. Look at that. That's exactly what we said, right? If the width of the rectangle is 14 feet, then the area is this. I say A is the winner, but let's keep going. Width is 14, then the length. No, the length would be 6 times 14, which is 84. No, that's totally wrong. If the width, no, that makes no sense. What are they talking about? Okay, 17, let's go. The circle shown has center O, circumference 144. Circumference of 144. I'm just going to write that down because I can also get the radius for this, because it's 2 pi radius, and radius would then be half of this, which is 72. So it's a radius of 72. And diameters, those are the length of arc PS. Let's highlight that. Length of arc PS is twice the length of, what is that? The length of PS is twice the length of PQ. So, by the way, and this whole thing is half. So I can just tell you, right? This is probably 1/3. This is probably 2/3, right? And then the two together make like the full thing. But that makes sense because what did it say? It said this is half, right? Yeah. So that's 1/3 and of 2/3. Well, or really 1/6 and 2/6, I should say, if we're going all the way around, but that's fine. Okay, now they want the, what is it? They want the length of QR, which is the same as SP. Okay, why? Vertical angles, and the central angle is going to determine that length of the arc. Well, if I know that, then if I'm saying that this entire circumference is 144 pi, here, let me actually update these fractions, and I'm going to show you what I'm talking about here. So we split it into 6 sections. We'd be like, This is 2, 6. This is 1, 6. This is 2, 6 and 1, 6. And that's going to make sense because, again, these two are equal because they're vertical, which means to get the length of, what was it, PQR, which is the same as SP, we take 2, 6, aka 1/3 of the entire circumference. So 1/3 of 144 pi, let me think, it is 48 pi. So I'm not even going to check the calculator, but I'm pretty confident with that. Let me just think about it for one more second. Obviously, it's not 72 pi because that would be half. Obviously, it's not 96 pi because that's more than half. 24 pi would be 1/3, which would be like the little one, PQ. So QR, again, 48 pi, boom, done. 18. Company that provides whale watching tours, takes groups of 21 people at a time. Let me drink some coffee. 21 people at a time. Well, the company's revenue is 80 per adult and 60 per child. So I always put it out like this. If the company's revenue for one group consisting of adults and children was 1440, nice little equation here, and wait. Oh, and again, we can do like a little equation. How many people in the group were children? So check this out. I can say the number of children is X. And they said this is a group of 21 people, right? Well, that means the number of, if that's X, the number of adults is going to be the difference of 21 and whatever the kids are, which is X. And now we got an equation, single variable, we're ready to go. So distribute. I'm going to try and do this mentally to the best of my ability. That's 160, 1680, I believe, is 21 times 80 minus 80x plus 60x equals 1440. Then we're going to combine these guys. That's negative 20x. I'm going to simultaneously subtract 1680 just to save a little bit of time. Don't do something like that if it's going to confuse you, but you know, as long as you can keep it straight, I think it's okay. And then we got negative 240. Last but not least, we're going to divide both sides by negative 20. Divide by negative 20. And the nice thing here is X, we already know is the variable we've chosen for children. If it wasn't, you just go back to your original chart and equation, and you can figure out what's what. But we're pretty confident here. The answer is going to be 240 divided by 20. Negatives cancel out. X equals 12. C is the winner. Boom, done. Now we're going to double check. So if we got 12 kids, that means we have 9 adults. So 12 kids, 12 times 60 is 720. 9 times 80 is also 720. Look at that. And that gives you the 1440. Boom, done. All right, number 19. Function h is defined by this. Graph of this has an x-intercept at a, comma, 0. Wait, h of x, graph of y. And this is the same thing. Has an x-intercept at a, comma, 0. The x-intercept occurs when the function value equals 0, which would be negative 7, by the way. And I'll show you why. If I plug in 0 for that, it equals 0 equals 4x plus 28. So then you can solve for that x value here, which happens to be that a value there. Negative 28 equals 4x. So you can see you divide by 4, you get negative 7. What about b? A y-intercept of 0, comma b. Well, this is in slope-intercept form. My y-intercept is 28. So b equals 28. What's a plus b? AKA negative 7 plus 28. That's positive 21. Boom, done. Number 20. One of the factors of this is x plus b, where b is a positive constant. What's the smallest possible value b? Okay. So this is, again, now these are kind of interesting questions that are newer, I would say like a slight twist. But let me tell you what like my general protocol is and what I'm going to do here, because you know, I'm not totally sure, but watch. We're going to do our basics. Factor, factor, factor. That's been one of my tips since day one. If you're not sure what to do, see a polynomial, see if you can factor it. So the GCF is 2x. Then I got x squared left inside. I got 21x. And then I got, what is that? Divided by 2 is 104, right? So you'll see if you redistribute this, you come back to the original polynomial. That's how we know it's correct. Then I'm going to factor what's inside. Okay, so we got boom, boom, boom. And we've got x and x. What multiplies to 104 adds to 21. Let's see. 4 and 20, wait, 5, maybe 8? No. Hold on, 4 times 26, right? Or 8 times 13. Boom, that's it. Look, 8 times 13 is 104. 8 plus 13 is 21. So they said one of the factors is x plus b, where b is a constant. What's the smallest possible value of b? All right. This is interesting. And I'm going to tell you why in a second. Sorry, 1 second. So the reason why this is interesting is because this is technically a factor. And you could rewrite this, right? 2x plus 0, x plus 8, x plus 13. Like, I can write this way. And then, actually, and I could even factor the 2 out, to be honest. You see? I could do this. 2 times x plus 0 times x plus 8. So, man, we're b. Oh, no, it says a positive constant. Never mind. So we can't do it. Okay, so b is then not 0. It's 8 because 0 is not positive. I was like, whoa, this is kind of trippy, but now it's cool. All right, 21. In the given system of equations, a is positive constant right there. It's also the y-intercept. The system has exactly one distinct real solution. What is the value of a? So check this out. That means that if I set these guys equal to each other, negative 1.5 equals x squared plus 8x plus a, and then I set everything equal to 0, this is, if we solve for x here, this will present the whatever, the solution. But, hold on one second, x squared plus 8x plus a plus 1.5. But we have an a, so we can't actually find the solution. But they just want the value of a that's going to give me one distinct real solution. This should trigger the notion of the discriminant, because when the discriminant, b squared minus 4ac equals 0, that's when you have one distinct real solution. So now we're going to plug and chug. B is 8. So it's 64 minus 4. My a value is that coefficient there, which is 1, times my c value, which is this entire thing, that constant, a plus 1.5. When does this equal 0? So we got 64 minus 4a, 4 times 1.5 is minus 6 equals 0. And then 64 minus 6 is 58 minus 4a equals 0. 58, add 4a to both sides, boom. And then we divide both sides by 4. It doesn't go in evenly, unfortunately, which makes me anxious, but it's probably fine. And then I'll just use a calculator. 58, excuse me, divided by 4 is 14.5. So we plug it in. Again, if you can graph, I don't even know if you can, what the capabilities are, the Desmos calculator for this is going to be provided, but it's fine because you could check it and on the graph if they allow it. If we plug it back in, let me think here. So I know how to test this actually. So let's say it's 14.5. That would mean the vertex would have to be right at something comma negative 1.5. It has to touch it. So the vertex here would be negative b over 2a. 2 times 1 is 2. So it's a vertex of negative 4. And then assuming we plug it in, if we get negative 1.5, we're good. So negative 4 squared is 16. Negative 4 times 8 is negative 32. So that's negative 16 plus 14.5. Negative 1.5. Verified. Boom. Done. All right. We're good there. 22, the function and time-wise, we got 10 minutes. All right. I think there's 6 questions left. The function f is given, which the table values represents f of x minus 3. What? Oh, got it. So this is a vertical shift down, which means, wait, we're shifting down. We got a polynomial at, so right now, if you plug in negative 6, you get 0. So then if you plug in negative 6, you should get negative 3, right? Which you do here, and here, and here. That's how you do it. So it's taking all the zeros. These are all zeros. Negative 6, negative 5, and 4. That zeros out the polynomial. So right now the function value is 0. When you shift it down by 3, they should all be at negative 3. That's what they're showing in B. That's what they're testing here. That's a pretty hard question, but that's the answer. They provided D probably because sometimes people, when you do horizontal, it's always the opposite. If it's minus, you're going to the right. If it's plus, you're going to the left. But now with vertical, it's all in sync. B is the winner. Done. 23. The function value Q, the value of Q of X decreases by 45% for every increase in the value of X by 1. Hold on. For the function Q, the value Q of X, hold on, let me just make sure the value of Q of X decreases by 45. Yeah, got it. So this is an exponential. It decreases by 45%. I already can tell you the answer is C, but let's keep reading it. If Q of 0 equals 14, which equation defines Q? So first, you can eliminate A and B because if you plug in 0, you don't get 14. Here, it becomes 1, you get 0.55. Here, you get 1.45. C and D work. Then it says it decreases by something, right? Well, if you decrease, you're not going to be having something in here that's greater than 1. This is an increase of 45%. A decrease of 45% is like 100% or 1 minus 45 or 0.45. That's why you have 55% because if you lose 45%, what you retain, and that's what's in here, is 55%. C is the winner. Done. 24. The graph of y equals f of x plus 14 is shown. Which equation defines f? Okay, well, obviously we need a y-intercept of 2 and a slope of -1/4. So -1/4, and then a y-intercept of 2 is C. Function notation, f of x, same thing as with y. We're good to go. Boom, done. Make sure no silly mistakes. Yeah. 25, side lengths of triangle RST are given. Boom, boom, boom. I don't care that they gave that. I'm going to make my own diagram, right? RS is 20. ST is 48. Not perfectly at scale. It's fine. And then TR is 52. Boom. What is the value of tangent of... oh, wait. It's a right triangle. And that means... okay, wait. I'm going to redraw this a little bit, okay? Here's why. Just to make it look more like normal. So this is here. I'm going to make the longest side 52. I'm going to make this side 48, and I'm going to make this side 20. And then I'm going to oops, darn it. I'm like making mistakes. Then I'm going to reorganize these sides. Boom, boom. So I want, what was it? TR to be 52. TR to be 52. TS to be 48, and RS to be 20. All right. So why is this better? Because then we got tangent. Oh, then there's a similar triangle. Okay. Then we got a similar triangle. So I'm going to draw it out like this. And it says UVW. Same order. RST UVW. U corresponds to R, which it does. V corresponds to S, which it does. T and W, which it does. All right. So they want tangent of W. The beauty is it's the ratio of the sides. So if they're similar, I don't have to calculate these values. I don't have to know them. It's the tangent of W is equal to tangent of T. The ratio is going to be the same for similar triangles. Tangent of T is opposite over adjacent. 20 over 48, which can be simplified by dividing by 4. That's 5 over 12. B is the winner. Done. All right, 2 problems left. Let's go. 26. Okay, 1 gallon of paint will cover 220 square feet. Okay, room total W square feet. Which equation represents the total amount of paint? Hold on, let me turn my feet warmer on. All right. Which equation represents the total amount of paint needed to paint the walls of the room twice? Okay, so here's how I'm going to think about it, all right? Let's say I have 2,200 square feet. No, let's say I have 220 square feet. That's what W is. So if I want to know how much I can, how many cans of paint I need. Well, I would just divide, like 220 I can do once. So I would just divide by the amount in the paint can, the total by the amount in the paint can. They'll say, oh, I need 1 can. But they said we need to paint the walls twice. So I need to be dividing by 440 essentially, right? Because if I've got, wait, am I doing that right? Hold on. Yeah. So 440. Wait. Yeah, exactly. So no, that's wrong. That's wrong. Wait a minute. That means 220. Wait, I'm messing up. Hold on. I'm getting confused. Wait, 220. So 220. So 440 would be 1. No. Oh my goodness. Wait, this is confusing me. Hold on. Let me just see if I can process this in real time. I know it's not 440 times W because that would make no sense. It's something with division. 220 times with the area doesn't make sense. Because if you have an area of 100, it doesn't mean you'd need 22. Like, that's ridiculous. So it's one of these two. I'm feeling like it's A because it's not actually, yeah, it's A. That's right. Because it's essentially what's happening is each can of paint is like doing half of what it normally can because we need 2 coats. So it's this one. And that makes sense because so think about if W is 220, right? I need 2 cans of paint. So here, if W is 220, if I plug it in, I get 2. Here, I plug it in, I get 1, and that's wrong. So again, if I need 440 square feet, I should need 2 cans for the first coat, 2 cans for the second coat. That's 4. Plug it in here, we get the right answer. All right. So that hopefully is a good example of thinking on your feet when you just, I don't know. I'm sure there's an even better way to do that problem. But sometimes you just got to go with the flow. All right. The last one, the number A. Watch how I'm going to do this. A is 110% greater than the number B. So this is a weird situation because it's saying it's not 110% of B. It's 110% greater than B. So here's B. There's 110% of B, and then we add the two together to get A. And then it says the number B is 90% less than 47. So basically, we're taking 97. So I can solve for B and then get A. Wow, this is a wild question. Okay, so let's see. Or I could also multiply this by 0.1. Let's do it's 4. So B would be 4.7. I'm going to do it mentally first. We're running out of time. And then I'll check afterwards in the calculator. And then I just plug this in to get A, right? So it's 1.1 times 4.7 plus 4.7. All right, 1.1 times 4.7 plus. Okay, so we're going to write that down. We're going to assume it's good, but we're going to double check it because it's a weird problem. So let me process again. So a number A is 110, because if we said a number A is 50% greater than the number B, we take 50% and we add it back. So we're doing the same thing. It's 100% greater than the number B. So it's 110% of B plus B. So that's technically also, 2.1B if we wanted. And then it says the number B is 90% less than. So 5% less than. So 90%, take 90%, subtract it, or 0.1, right? That's just, I'm like doubting everything now. Let me just do this math. Okay, and then 47 minus second answer. Yeah, duh. Of course, that's 4.7. Okay, I think we did the work right. We got 2 minutes left. I'm pretty happy. Let's stop the clock. Let's grade it. Let's see how we do. Again, if I get something wrong, it's all good. I will just figure out why, and then we'll talk about it. Let's go. Boom, boom. Number 1 to the answers. All right, module 1. Here we go. CCDDC. Wait, let's make that bigger. Red pen of justice. CCDDC. Beautiful. Then we got 180 and 5. Boom, boom. Then we got 8, which is, let's do 8. A, B, A, B, D. Okay, watch this. A, B, A, B, D. Beautiful. 13. We've got 26.25. Yep, they allow it. 14 is 182. They allow that. Perfect. D, A, B, C, A, B. Dab, cab. C, A, B, D, A. Wait, hold on. D, A, B, C, A. What? Oh, that's. Oh boy. Did I make a mistake? I got a question wrong. No. Okay, wait, hold on. Let's look at this. What a bummer. A plus B, negative 7 plus. Hold on. So 18. No, I'm looking at the wrong thing. 19. Sorry. I was looking at the wrong thing. 19 is A. Oh, I went over and looked. Okay, sorry. It was right. 20 is 8. I don't know if you can see this, but it looked like a B. That's why I got confused. 21 is 14.5. That's correct. Okay. So far, we're golden. Now we get to some of these tougher questions. 22 was B. 23 was C. 24 is C. 25 is... Dang it. I got a question wrong. Okay, let's mark it, but we'll go back to it. 25... No, it's right. I keep looking at the wrong thing. Sorry. 25 is B. Phew. Okay, and then 26 is A. Let's go. And then 27. Yes, 9.87. All right. We got them all. Let's quickly take questions. I got to bounce pretty soon because I got a tutoring session. So let me see what we got here. Okay. Positive constant. Number 24 is wrong. Oh, wait, Chris, I got 24 right. This one, I got it right, didn't I? Or did I make a mistake? Wait. Oh, it is wrong. No, I made a mistake. You are correct, my friend. This one is weird because, I misread it. I went too fast. Okay, thank you for catching that. Darn it. Sorry, guys. Went too quickly. So here's why it's wrong. 20, this says the graph of f of x plus 14 is shown. Read it too quickly. I missed it. So these are good things to note that maybe they're going to throw out more often on the new SAT. I mean, they can ask this on the regular one. I guess I just, rushed. So let me quickly explain why this is incorrect. Sorry. So f of x plus 14 is shown. They want f of x. Well, that means then we're dropping it by 14, right? So right now it's here. That would come down, right? Because that means it's vertically shifted up. So it would drop down. So the y-intercept would no longer be at 2. It'd be at 2 minus 14, which is negative 12. So that's this guy. So the slope is the same. The slope is the same, negative 1/4, which I have all. It's just a question of the y-intercept. I should have known not to go so quickly because these are the last few questions. Are probably the trickiest, and it was too easy, right? So that's a good indication. Hopefully you learn from that one. You know, learn from my mistake. But that's why we do it. It's fun, and you never know what's going to happen. So I hope this was valuable for you guys, and I hope you liked it. If you did like this video, make sure to click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining. I really appreciate it. Best of luck in December. We'll do more leading up to the December test, like of current SAT stuff. They'll probably start next week. But right now, we're going to knock out a couple of these. We'll do another module later. So thank you guys so much, and I will see you in the next video. Take it easy.